Ladies and gentlemen, this is not Eva Hjelmered. She is hospitalized due to climate change. She was lured out on skis, and that was not a good thing. We have snow this year. So I wish that we all send her a greeting and hope for a quick recovery. So I will act as a stuntman today, or stand-in at least. Given a very short notice, I will try to give this presentation. I know she had prepared a much better one, but at least we made it here. I am chairman of the Union of Baltic Cities Energy Commission, and we are working a lot with energy-related issues. One of the issues is actually try to be as efficient as possible. And another thing is that we are living on the shores of the Baltic Sea, and we know that the Baltic Sea is quite heavily polluted. So we all try to do something about this. Situated in southeast of Sweden, we have this seasonal climate by autumn, winter, and spring, where it's quite cold. And that actually results in that when our waste water treatment facility should try to reduce the nitrogen content of the water, it's too cold for the bio process to actually take away all the nutrients from the water. We need to increase the level of the temperature to at least 20 degrees, but it's too cold. So then we came up with the idea to use the return of the district heat water that circles around and warming our houses. So when it's on its way back to the combined heat and power plant, we'd say, can't we use the energy that is left in the return water to actually heat exchange the wastewater so we can actually get up the temperature? How will that affect the nutrients, and how will it actually affect the Baltic Sea? That is basically what our project is all about. Increase the temperature of the sewage water in cold climate during the cold season and get a better purification of the water. This applies to all regions where they have cold climate. So it's not any particular just for our region, but I think it could be in many other places. The win-win situation in this is actually that when the return water to the CHP plant, the combined heat and power plant, has a lower temperature, they can increase the production of electricity. So it's a win-win situation. Out of this, we get higher yields of electricity, that is actually a clean tech process, and we get better, a cleaner water to the Baltic Sea. So this is iTest, and this can actually be applied to all kind of wastewater treatment plants, irrespective of where it's located. So this knowledge, we want to test how much does it affect, and how much effect does we get out of the electricity production when we use this technology. No one, I guess at least, very few around the Baltic Sea or in the cold climate zones can actually fulfill the nitrogen objective in the Directive 98/15 from the European Union. We actually have been sued by the European Commission for not fulfilling that kind of directive. And we have no way of solving it because it's too cold. But now we actually have, but we have made some tests. We think we have a solution that can be implemented in full scale that really actually gives all of us a chance to implement this simple technology to just heat the wastewater with spill heat from other sources. It could be any kind of industrial spill heat that we could use. It doesn't have to be from a CHP plant. It could be from a process industry or anywhere where you find low-grade spill heat. Normally, spill heat is actually considered an asset if it is a higher temperature than 90, 100 degrees. But here we are talking about 40, 50, 60 degrees, and still can make a very good use of it. What do we hope to should be the result and output of this test? According to our pre-studies, we can actually meet the standard. We will reduce the outflow of nutrients by 35% and come below the directive level. The colder, better it gets. The less power consumption at the waste sewage treatment plant, about 30% more efficient from an energy point of view, and the reduced cost for treatment of sewage water in cold climate of 5 to 10% compared to conventional sewage treatment, and 4-5% increase in energy production if it's connected to a combined heat and power plant. So, a win-win solution: environment, energy, and climate all linked together. Make intelligent use of energy resources that we have in our communities and in local areas, and also applicable to existing installations. How do we actually plan to disseminate this kind of findings? Well, we thought there's only one way to convince you, and that is to use real facts and figures. So what we will do is actually to create an online sewage treatment plan. It's not the actual image, but what will happen is that we will have sensors in the plant, sensors that can communicate online and tell the system all the values of temperatures, flows, etc., etc. And we bring that to a website. And then you can go in and fill in your own parameters for your own sewage treatment plan, and you can test run the whole concept and see what the output is. And it will actually look like this kind of dashboard with gogs and meters and everything. So wherever you are around the Baltic City, you can actually just enter how much sewage you have, the temperature right now, and see what the outcome would be based on our real actual findings. So it's a simulation software based on actual testing in a pilot plant data. And it will be all online, so you can actually just inform your sewage manager back home that make a test and see how much efficient and how much money you can save. I think that's a good idea. Thank you very much.